Handling new software installation issues. In this nugget, we take a look at some of the things that a desktop support technician may be asked to troubleshoot with regard to administrators installing new software on users' computers, and moreover, how IT managers, and perhaps with the help of DSTs, can control new software installation on the part of those employees. First, we're going to consider installation permissions, which is going to involve a detailed consideration of user account control, or UAC. We're going to find that Microsoft has refined this technology quite a bit in between Windows Vista and Windows 7. We'll then look at App Locker, a brand new feature to Windows Server 2008 R2 and Windows 7 that's meant as a replacement to software restriction policies, which, as we'll review, were quite difficult to manage in practice in Windows XP and Windows Vista. Third, we'll look at driver signing, what digital certificates are, what code signing certificates are, and what the big deal in general is with driver signing in Windows 7. And finally, we'll look at licensing options. Licensing in Windows has historically been a thorny bush. We're going to look at what the situation is currently with Windows 7 Desktop OS. There's a lot to do in this nugget. Let's get to work. Installation permissions. Historically, in Windows NT line business operating systems, and of course NT line makes us think of, rather than the consumer line, which was known as Windows 9X, and then went up to Windows ME, and then went up to XP Home and Vista Home, and now of course we're in Windows 7 Home. In this course we're concerned with the business class versions of Windows. That started with Windows NT Workstation 4, went up to Windows 2000 Professional, went into the Vista Business, Vista Professional, Vista Ultimate, Vista Enterprise, and then we have the same thing with Windows 7. Specifically with regard to software installation on business class Windows, only administrators are allowed to install software by default. Now in Windows Vista, Microsoft took this up to another level by implementing what's called User Account Control, or UAC. UAC was considered by some in Windows Vista to be a little bit heavy-handed. In other words, it seemed like you were prompted for either consent or a password to do what some users considered to be fairly mundane things. To that end, I think Microsoft has refined user account control and made it, well, number one, a little bit smarter, number two, a little bit easier to control. But the bottom line is the same. User account control deals with privilege escalation. It's been a long-standing best practice in Windows OS, again, at least the business class where we have multi-user operating systems, that even as an administrator, you should run your operating system in the context of a standard user account. That's how things are done in Mac OS X and the Linux Unix world for years. So the way UAC works in Windows 7 by default is that even if you're logged onto the system as a domain or local administrator, you're still running largely in a standard user access token. The great benefit from that from a security standpoint is if malicious software were to infiltrate the computer and run code, that code would only run as high as the currently logged on user's access token, which by default in admin approval mode means that even administrators have a standard access token by default. And then if that malicious code tried to do something that required administrative privilege escalation, you would see the secure desktop, which means that the screen goes dim and you receive either a consent or a password prompt, depending upon whether you're logged on as an administrator or a standard user, before you can continue. The secure desktop means that no other process is allowed to run currently other than the UAC one. And the idea here is that you want to educate your users not to just blindly put in their password if they do have administrative privilege, or if they're already local administrators, just to consent and go ahead. You should educate the users always to read the UAC prompt to make sure that this is an action that they're initiating themselves. So admin approval mode means, as I just said, if you're logged onto a Windows 7 box as an administrator, you don't have to put in your password each time you take an action that requires privilege escalation. Examples of privilege escalation tasks would include installing software, certainly updating a device driver, and opening up sensitive control panel applications. If you're a standard user, as I said, you're not prompted for consent, but you're actually prompted for administrator credentials. Now, how do we deploy UAC? In a typical business environment, we use good old group policy to deploy those UAC credential prompt settings. And even more granularly, we can use the local security policy or the security policy group policy options to create perhaps a template using those settings and then deploy that way. We're going to cover the subject of UAC in our upcoming demo, so you'll actually be able to see these concepts in action. Controlling software installation. Many IT managers, with the help of DSTs, want to limit what ordinary end users can do on their computer, including restricting the ability to install software. Now, why? Is this just the IT department on a control trip? No, it's not. There's actually some very good reasons why we want to limit and control what our users can do on their computers, again, in particular software installation. One is security. If we don't strictly control what users can install, then users may go ahead and install software like, for instance, WeatherBug. Nothing against the WeatherBug company, but software like that has historically been a pain in the behind to IT managers because it makes so many phone home calls on the internet. It can produce spyware pop-ups, etc. Another thing is the issue of support. Our support center has a service level agreement with its user base determining, well, we support software packages X, Y, and Z. Anything else is outside that realm of support, and legally, professionally, we're not bound to support you. If users are allowed to install their own software, then invariably, not knowing any better, they're going to file support incidents with the support center saying, my WeatherBug's not working, can you come fix it? This is going to reduce productivity, create extra junk in our support center incident database, etc. We want to avoid that. And finally, by making sure that users in the organization use a consistent set of software, it does improve productivity because users aren't downloading Winamp and all these other games and unnecessary applications, potentially hosing up their system, which results in a denial of service for at least that user, keeps them focused, in other words. And of course, we have consistency because what the users are running on their desktop is fully consistent with what we're supporting in the IT department. Now, two ways to approach software installation. Exam alert here, I'm going to put up an asterisk. One differentiating factor between the old school software restriction policies and the brand new app locker is the user base or the client base that's supported. If you have a mixed environment, that is to say Windows 7 and down-level clients like Vista, Windows XP, then you're going to have to use a mix of both of these technologies or just go with software restriction policies. The new app locker will only work on the server side if you're using Windows Server 2008 Release 2, R2. And on the desktop side, only the Enterprise and Ultimate SKUs are supported. In point of fact, in this Nugget series, a vast majority, really, of the technologies that I'm going to show you pertain only to the Windows 7 editions Enterprise and Ultimate. Enterprise is obviously a business stock keeping unit or SKU that's available only to volume licensing customers. Ultimate gives you all the features, the whole kit and caboodle, but it's also an edition that's accessible to retail channels as well. Alright, so I mentioned that software restriction policies work with pretty much all contemporary Windows versions. App Locker is Windows 7 only. Little bit on software restriction. We're not going to spend a lot of time on this. We're going to do App Locker. But if you've ever used software restriction policies, they're deployed via group policy, as is App Locker, and it uses specific rule types to block or allow certain types of applications. Of course, those apps are of your choosing. And the rules that group policy uses to detect that software on the user's computer are as follows. And by the way, these 5 rules that I've listed are ordered from most specific to least specific. In other words, the hash rule is by far the most granular, tightly controlled, and specific rule, whereas the zone rule is pretty wide. In a nutshell, and we're going to cover these rules in App Locker because they exist in App Locker as well, at least most of them do. A hash is a one-way function. You might have heard of MD5. That's a popular hashing algorithm where you can create a digest or a fixed-length alphanumeric string that serves to uniquely identify the source file. So we could take a particular .exe file, winword.exe, run it through MD5, come up with a specific digest, let's say 0123, and this is how group policy can detect whether that software is trying to come down, or if the user has a disk on hand, or if they've brought in a thumb drive and they're trying to install it. If group policy detects that exe coming down with that hash value, it'll match the rule. So it's very specific. Of course, the problem is, if a user tries to install an older version of that exe or a newer version, that's going to result in a different hash value, so this rule won't pick it up. A certificate rule deals with digital certificates, a publisher certificate, for instance, so you can allow or block software based on the vendor's identity. Again, the issue with that is it can sometimes be too broad. You're blocking everything from software company XYZ, when in point of fact there is an exception. One neat thing about AppLocker is that, as you'll see, is that we can create exceptions to rules. A path is going to block any executable code the user is trying to install to a particular path. C program files, WinRAR. C program files, WinZip. Whatever. I'm just picking on those apps. Of course, that's easy to defeat because the user can install the software in an alternate path and it won't be picked up by the software restriction policy. Zone deals with software coming down from Internet Explorer zones. If a user has their own software on a thumb drive, that's going to be defeated. And then we have custom rules. Bottom line, friends, software restriction policies in practice are really difficult to enforce because they're so easy to get around on the part of the user. You have to constantly update hashes, certificates, paths, etc. AppLocker is meant as a replacement to software restriction policies that takes all the best features of software restriction and puts them all together and adds some even more user-friendly features on top of it. I think you're going to like AppLocker a lot. AppLocker continued. As I've previously mentioned, AppLocker is a much more granular but easier to use method for IT managers to control new software installations on Windows. Now, here's another exam alert, and this is just a practical point that you need to remember in deploying AppLocker in your Windows 7 network, is that you have to have the application identity service running on all affected computers. Of course, application identity is a built-in Windows service, and if you've been playing around with Windows 7 and gone into the Service Control Manager application, you may have noticed this service and thought to yourself, well, what does it do? Now you know. Application identity is tied into AppLocker. Specifically, let's take a look at the rule types. First, we have the general categories of AppLocker rules, the ways you can restrict the software in terms of what files. First, we have default rules. And what you're going to see here, actually, let me preface this discussion. If you've ever done firewall management, firewall rule management, perhaps not so much with Windows Firewall, although actually the Windows Advanced Firewall tool gets closer to this. But if you've ever done honest-to-goodness hardware like Cisco ASA Firewall, etc., that kind of administration, or even router administration, you know that you have to be very careful in how you stack your rules and make sure that, for instance, administrators are going through all those rules, cutting through them like a hot knife through butter, and you're capturing user populations on your rules in the desired way. Typically, the first rule that fully matches the connection parameters of that user will be captured by that rule. Similar kind of thing with AppLocker here. Now, a default rule is essentially where you're creating a global exception for administrators. Administrators can install all software. And you're also going to see restrictions on trusted folders. In Windows Vista and Windows 7, the Program Files folder is, as you know, I'm sure, the default location for software installs. And you'll find that users who try to install to Program Files will invariably be prompted with a UAC elevation prompt. So that's our default rule. And what's cool about default rules is that you can delete them. You want to be careful, especially deleting the administrator rule, because it's possible to lock everyone, including administrators, out of installing or launching software. AppLocker affects not only installs, but currently installed software as well. So be careful with that. The good news is that you can reinstate or recreate the default rules to get you back to level 1, so to speak. Alright, we've got executable rules, pretty straightforward. These are rules that govern executable program files. In Windows, those are .exe and .com. Windows installer rules will pick up the Windows installer MSI and the transform MSP files. Script rules will look at your shell scripts, BAT, CMD, and also your Microsoft scripting files, VBS and JS. Now, you might be noticing a trend here. This is pretty Microsoft-centric, isn't it? It doesn't seem to be taking in place what if someone were to have a Python script file with PY. You'll notice, again, as I said, this is a pretty Microsoft-centric list, but that's the way we've got it going on. Now you can extend this, of course, fortunately, to add additional extensions, but this is the default collection. And then finally we have DLL rules. Dynamic link libraries are collections of functions and procedures that will be attached or linked to an associated executable file. In Windows, those DLLs take the extension DLL or OCX typically. Now, take those rule categories and then how do we specifically enforce an allow or a block? We can use publisher certificates, and you'll be amazed, I think, on how much easier it is to use digital certificates as a validation with AppLocker. You can have AppLocker scan a directory and automatically pick up applications with their publisher certificate, or just have AppLocker extract the certificate from a file that you point to as a reference. It's really awesome. Hashing still exists. Pathing still exists if you want to deploy that way. Before we do our AppLocker demo, let's take a look at this final list of points to make sure we're not forgetting anything for our certification exam. You should know, as I've already said, that AppLocker is deployed via Group Policy Objects, or GPOs. We do have the ability to automatically create rules, so we'd set up a reference computer with our allowed software, or just in general the software that we want to control. Tell AppLocker to scan the directory and it picks up those executables, which can be very efficient, because as we're going to see, the granularity that you have with AppLocker, you can block, for instance, particular versions of an application. You can allow all applications from a particular publisher except a certain list or one in particular. That's the exceptions piece. And even on the testing side of things, of course, measure twice, cut once, and especially in IT, we want to make sure we're thoroughly doing our testing. You can deploy AppLocker policies in auditing mode, where you get a report to tell you what would be blocked and what would be allowed for particular users and groups without actually having those rules physically enforced, you see. Final points to remember, again an exam alert for you. AppLocker rules will always trump software restriction policy rules. So you want to be careful if you're in a mixed environment, Windows XP and down-level client operating systems, where you're using both software restriction and AppLocker. Probably want to migrate, keep those rules in separate GPOs, and target the GPOs to your client operating systems specifically. Also, block rules trump allow rules. That's standard firewall behavior. If you have two conflicting rules, one blocks, one allows, you're going to find that blocking takes precedence. In our first demonstration, we're going to log into a standalone Windows 7 box, and I'm going to demonstrate user account control functionality as well as AppLocker. Now you should know on the front end, although we're using local group policy on that Windows 7 box, we'll see the very same options in terms of the group policies themselves on a Windows Server 2008 R2 machine. So just know that we're seeing the same thing there. Let's get to work. In this demo, we're going to begin with the consideration of user account control, or UAC management, in Windows 7. So to get started, let me just show you some of the ways that UAC manifests itself. One way is that the software vendor themselves may write their installer in such a way that it invokes or requires the administrator access token. Now you notice here we see examples of both of those. This is the 7-zip archive management software, and you'll notice that it does not have the user account control shield on it. By contrast, we see the CCleaner and also the Smart FTP software. Both of these are installer packages that have the UAC shield, so we can rest assured that if we double left click to install one, we're going to see the UAC prompt. I'm logged onto this machine as a local administrator, so here we're seeing the default behavior. This is what's called a confirmation prompt. Note that I don't have to put in my password, I just have to acknowledge that I do want to install this software. And what's cool is that this publisher has included their digital certificate with the installer, Piriform Limited. And if we click Show Details, note that you can actually display that digital certificate, and moreover, come over to Certification Path and see who signed it. In this case, VeriSign. That's very good and very honorable of this company to do that. Another way that we'll see that user account prompt is if we go into a control panel item. For instance, if I right-click Network in the Start menu to open the Network and Sharing Center, and then I change my adapter settings. Although the icon itself doesn't display with the UAC shield, if I right-click, you'll notice that as an ordinary user, I can run network diagnostics, I can look at the status of the connection, but if I want to disable, bridge, rename, or look at the properties, again, I'm prompted, well, if I already recently consented to administrator elevation, it takes me through. Otherwise, I'm going to hit that prompt. What I'm going to do now is log off as the trainer account, which is, as I said, a local administrator, and I'm going to log on as a standard user, a fully standard user named student. Now then, let's do some of the same things. I'll Windows R to go into my tools directory. We'll change our view to large icons so we can see those shields again. And when I double click to install the software, we get the secure desktop, but check it out. As a standard user, the default admin approval mode now is saying, because this person is an ordinary user, we have to type an administrator password. And the only other account on this machine that's active and has administrative credentials is the trainer account, which you see right here. So if I just click yes, it's going to keep prompting me. If I put in the trainer credential, then I'm allowed to go ahead with the installer. Same thing goes for control panel items, of course. If I open the Network and Sharing Center, go into my adapter properties again, I'm not going to get to that option unless I have administrative credentialing. There's the great beauty of UAC. Let's take a look at the group policy settings, and then we'll move on to another subject. With respect to UAC group policy, let me pop open the editor and show you where to go. First of all, to open the local group policy editor in Windows 7, what I did is I did a Windows R to invoke the run prompt, typed gpedit.msc, and then in order to make sure I was launching this MMC console with administrative credentials, I used the very helpful shortcut Control-Shift-Enter. Once we're in the local group policy editor, which again is identical to what you'll see on a Windows Server 2008 R2 group policy editor, that's why I'm just staying here on Windows 7 for convenience for now. If we navigate under Computer Configuration, Windows Settings, Security Settings, Local Policies, Security Options. Let's stretch out our screen here. We can come down to the very bottom and you'll see a lot of user account control options. Now you'll notice that few of them are disabled, but by and large they do have settings already set for them. For instance, this one's important, the behavior of the elevation prompt for administrators in admin approval mode. And if we double click that, prompt for consent for non-Windows binaries. You have a lot more options with UAC in Windows 7 than you did with Windows Vista, for instance. Behavior of the elevation prompt for standard users. So these are probably the most important UAC policies because they define how frequently the UAC prompt hits those users. And you'll notice that ordinary users are prompted for credentials. You can also automatically deny elevation requests, prompt for credentials on the secure desktop. Now, of course, this group policy is cool because it enables us as IT managers to standardize these settings across multiple machines. But you should also know that if we open the Start menu and just type User Account Control, we can hit up the control panel item for user account control, change user account control settings, and this is actually quite an advance from UAC in 7 coming from Windows Vista. You'll notice here we have a slider. Choose when to be notified about changes to your computer, and this is going to be a computer-specific setting that can be overridden with group policy. You'll notice also the UAC shield. In order to make the change, you do have to be an administrator. The default UAC option is to notify me only when programs try to make changes to my computer. Don't notify me when I make changes to Windows settings, all right? You can say the secure option, the ultra secure option, always notify me when programs try to install software or make changes, or if you make changes to Windows settings. And then you can come down here, notify me only when programs try to make changes to my computer. Do not use secure desktop, in other words. Obviously, that's not recommended. Secure desktop ensures that you're interacting not with some malicious or rogue process, but only with Windows. And then we can come down here. The least restrictive option is never notify me. Obviously, that's not good. The default is kind of a conservative setting, but not too conservative. All right, to look at the rest of these, detect application installations and prompt for elevation is enabled. And the final one we'll look at here is run all administrators in admin approval mode, and that's enabled. These are good sound options in my opinion, and very useful as defaults. Now let's move on to App Locker and software restriction policies. Again, we're in Local Group Policy Editor here on Windows 7, but we could just as easily be in Group Policy on Windows Server 2008 R2. And if we come down again, basically the same area as where we saw UAC, Computer Configuration, Windows Settings, Security Settings. I want you to see two folders here. We have the Software Restriction Policies, which is, as we know, the previous iteration of this. And if you right-click, you can pop open the Software Restriction Policies folder and look at your traditional rules. I mean, all those rules are in place from previous versions of Windows. What we're concerned with is the new node underneath Software Restriction Policies called Application Control Policies. And if we click App Locker, we see this really nice interface where we can click to learn more about App Locker. We can read about the server and client versions of Windows that are supported by App Locker. And then what you'll want to do to kick things off is to configure rule enforcement here. You'll notice that App Locker is turned off by default. And on enforcement, we can configure executable rules, Windows installer rules, or script rules as previously discussed. In this example, we're going to configure executable rules. And once you've configured it, you can choose to actually enforce the rules or just do an audit like we discussed before. In this demo, we're actually going to enforce those rules. Now, advanced is where you can do the fourth rule type. It's on a separate page because DLL rule enforcement can have a serious effect on CPU time. So you want to be really careful about using this. I mean, think of the overhead involved in scanning and parsing DLLs. You have so many of these. Every executable program file on the system is going to have one or more DLLs. So be careful. Here we're just going to enforce the executable rules. We'll click OK, and then if we expand App Locker, click Executable Rules, there's nothing there. But if we right-click and choose Create Default Rules, we can bring in those three that I mentioned before. Here we'll look at them specifically. The three default rules in App Locker for executables are, as you see, they're allowances. Two of them hit everyone. The third and final one, which is where your catch-all rule is, if administrators are on this system, they can run all applications no matter where. The path is just an asterisk, and there's no exceptions. Of course, you want to leave that one alone. The other default rules are members of the Everyone group to run applications that are located in the Program Files folder. We'll remember that Program Files is a trusted location in the Windows file system. We have the environment variable program file set up as the path here, and there's no exceptions. The third and final default rule allows members of the Everyone group to run applications that are located in Windows. Obviously, this makes sense so they can have full access to the Windows environment. Windir is the appropriate path environment variable and no exceptions. Now in our example, we're going to play around with some software I've installed. I've installed the Microsoft Office 2007 suite, and what we're going to do is create a rule that blocks the Microsoft Office 2007 suite except for Word. We'll allow Word, but the Office tools, Excel, PowerPoint will be verboten or forbidden. So how do we do that? We can right-click the executable rules, and the same rules apply, pun intended, for Windows Installer and Script. We're just going to, in this demo, work with executable rules. We'll right-click and choose Create New Rule, and it kicks open this wizard. And you notice that the wizard starts with Before You Begin, and then we deal with permissions, conditions, exceptions, and then we finish. Let's kick this off by clicking Next. In terms of the rule permissions, are we allowing or denying by default? Of course, we're going to deny. User or group, everyone is the default, but we can come in here and change that if we want to. For instance, the built-in users group. In an Active Directory environment, if you're deploying this as a policy in your domain, you'll want to choose perhaps domain users instead. Next, we have our condition. Is this going to be a publisher rule, a path rule, or a file hash? Publisher is really flexible, as you'll see in just a moment. Path is where you, just like with software restriction policies, can set the rule to a particular file spec, and then file hash allows you to run a hashing algorithm against an executable. Of course, path and file hash perhaps have some of the problems that software restriction policies do. You can click more about rule conditions to get help along the way. We're going to do a publisher rule here, and it tells us here to browse for a signed file to use as a reference. So Windows will automatically extract all of the publisher metadata from the associated digital certificate. So we're actually going to browse out to C Program Files, Microsoft Office, Office 12, and I'm going to pull in PowerPoint as a reference file. And check this out. This slider here allows you to scope your condition. You can say, I want to, in this case, block everything from the publisher Microsoft. I want to block the product name, which is the Office system family. I just want to block on the executable, or you can even get granular if the user has multiple versions of an executable. You can use custom values and say, I want to only allow this version and below, this version and above, or I want to match exactly that version. Pretty cool, isn't it? We're going to set our slider to match the entire Microsoft Office system for 2007. Let's click Next. And here we have exceptions. The primary condition, again, is the 2007 suite, so it's going to block all of those applications. In this exception, we can do a publisher, path, or file hash exception. I'm going to keep it at publisher. We're going to click Add, and again, we do the same thing. A publisher-based exception, we browse for that file. And in this case, remember, we're going to go into Office, Office 12, and we're going to allow WinWord. And we're going to match this, let's say, to the file name, winword.exe. Click OK. Next. Enter a name to identify this rule, name and description. I'm going to take this metadata away, and we're going to say block Office 2007 except WinWord. Click Create, and we're done. We now have a new rule in our rule set, a deny rule, and it gives us the name, the condition, and then whether exceptions are configured. Cool. Now, in order to make this go into effect, we're going to have to refresh our group policy. So I'm in my search box, going to type command prompt, and we'll open up an elevated command prompt by right-clicking and selecting Run as Administrator. And we're going to use gpupdate /force. No change between this command. It's been around for a long time. Group policy update. Cool. Now we're going to have to log off as our trainer and log on as a member of the users group in order to test this policy. Let's do that now. Okay, we're logged onto the Windows 7 box as our student ordinary user, and I've opened up an elevated service control manager. This can be done by doing start services.msc and then Control-Shift-Enter to make sure to do the elevation. I want to make sure I don't forget to remind you that in order for AppLocker to work, you have to have the application identity, or also called App ID service started, which, as you see, I've done. So to test this out, we'll open up all programs, open up Microsoft Office, and try to open up an application that's covered by AppLocker. Now you'll remember, we're blocking all Microsoft Office applications here except for Word. So it's saying this program is blocked by group policy. For more information, contact your system administrator. On the other hand, notice that Word opens up just fine. Device driver signing, especially when Windows Vista came around, and even more specifically 64-bit Windows Vista, this caused quite a furor in the IT field because IT managers in some cases were burned by adopting 64-bit Vista, I guess, a little bit too early. That was kind of the key word to describe Windows Vista in general. Too early, I think. Because they realized that Windows Vista 64 required signed drivers. So if we had devices, hardware devices that we needed to support in 64-bit Vista, and those vendors had not produced digitally signed drivers, then Windows Vista simply is not going to allow those drivers to be installed. Interestingly, Windows 7 carries on the same tradition, but again, only for 64-bit platforms. Windows 7 64-bit requires signed drivers. Now you can disable the signing. That's not particularly recommended. We'll talk about that in just a minute. But we've still got that situation. So it seems clear that Microsoft has a strong preference for their operating systems to require digitally signed drivers. And quite frankly, between you and me, there's all the great reasons for that. And then, as we'll talk about, there's some moolah involved going to Microsoft. First, though, let's back up and look at this first bullet point and ask ourselves, what does it mean to have our device driver digitally signed by its vendor or by its creator? To take a step even further back, what's a digital certificate? An X.509C code signing digital certificate is an electronic document that a vendor In particular here, let's say ATI or Microsoft themselves or some hardware vendor attaches to their code, to their DLL files, their .sys files, to provide authentication and integrity. These are the two main functions of digital certificates in general, but here we're talking about a specific type of digital certificate, not a web server or e-commerce digital certificate that you might be used to dealing with for doing HTTPS-based e-commerce transactions, but code signing digital certificates that are digital certificates, as I said, attached to your device driver files. Authentication is ensured because you can view that digital certificate on the driver and take a look at who signed the certificate. Is it a trusted root certification authority like Entrust or VeriSign? And if so, the point is, if that driver really trashes your system and you go to call up the vendor and they've packed up all their suitcases and taken off, you have some point of recourse because VeriSign in this example verified that that vendor was who they say they are. So there's a point of trust here. Also, another way to do it, especially for internal shops where you're signing your own code, you can create your own trusted root certification authority, digitally sign your own certificates using your own internal CA, and keep your web of trust inside your organization. Of course, best practice, you never want to use an internal CA to sign code and then give those to your external customers out in the world, because there's the issue, are you really trusting that this digital certificate and this code is coming from who they say they are? At least with Entrust, Thought, VeriSign, the idea is there's been some validation taking place to make sure that the code signer is who they say they are. Second point that's really cool about digital certificates is that they guarantee integrity. On a digital certificate, you have what's called a digital signature, which is a specific value that was generated with the private key of the vendor or the actual code signer. And this is obviously a pretty unique signature because it was signed, so to speak, with the pen, quote unquote, of the private key that's held only by the owner of the certificate. And what you can do, or what your browser can do really, is validate that digital signature by using the associated public key that matches the private key that ships with the digital signature. Really, the digital certificate contains three important bits of information. It contains the metadata, or the human readable information about who signed the certificate, who the code signer is, etc. We also have the digital signature, which is a digest produced by the private key of the code signer, and we also have the public key that's associated with the private key. With public key cryptography, you have that matching key pair, you distribute the public key to all of your constituents, and you keep the private key very secure. But anyway, to finish this out, your browser can use the public key, or Windows actually, can use the public key to run against that digital signature in order to make sure that not one bit of that associated code to which the certificate is attached has been altered. You see, that digital signature is going to change, similar to how a hash function works, if even one bit of that code has been changed. So if somebody tried to inject Trojan horse software into your code, that would corrupt the digital signature, and when you receive the digital certificate along with the code and run that checksum with the public key, you'd get an error, you see. So authentication and integrity are the big deals, and that obviously enhances security, doesn't it? So driver signing is a very good idea. Now, I mentioned a little skeptically the money aspect. Microsoft has their own code signing approach called Authenticode. So you can purchase a digital certificate, a code signing certificate from Microsoft. And by doing this, by going through their testing and applying for an Authenticode certificate, you can tell your customers that you've passed the Windows Hardware Quality Lab's compatibility standards, and you can be listed, your hardware that is, can be listed on the Microsoft Hardware Compatibility List online, and it is a good idea, frankly, for vendors to do this because they can kind of assure their customers that their hardware will work with certain versions of Windows. Now, I think the money aspect, the fact that Authenticode costs several $100s a year, may dissuade some hardware vendors who may be smaller or just unwilling to pay that money, so they're not signing their drivers. Of course, the trend is more and more Microsoft is pretty much corralling hardware vendors to sign their code, but exceptions still exist. So like I said, it's possible to disable signing just so you know how to do it, although I don't recommend it. You can run the following commands from an elevated command prompt to modify the boot configuration database in Windows 7, and this puts Windows 7 in what's called testing mode, where you're disabling the operating system's ability to check whether device drivers are signed. Obviously, this completely compromises security on a production machine, so you only want to do this if you absolutely have to, or preferably in a testing environment. Deploying device driver certificates and managing these device driver signing options, again, we have group policy to do that. Every Windows 7 computer is going to have a certificate store. When you want to install code signing certificates in advance on users' computers, you want those to wind up in a certificate store called the Trusted Publishers Store. And finally, we have the File Signature Verification utility, or SIGVerif. We'll take a look at this in the upcoming demo. This is a tool that's been around for a long time, and in Windows 7 we can fire it off to have it scan our driver store to detect any drivers that have not been digitally signed. So what do you need to know about Windows 7 licensing for your 7685 exam? Just a little bit, actually. Let's take a look at this helpful diagram that I pulled from Ed Bott's wonderful blog at zdnet.com. This table attempts to summarize some of the very confusing points about Windows 7 licensing. As DSTs and for the 685 exam, we're just going to cover the high points and paying particular attention to the enterprise or volume license options. Of course, the whole purpose with licensing and product activation is to make sure that piracy isn't taking place. For instance, with Windows XP, the enterprise or volume license associated with XP could be used for as many installations as possible. It was on the IT manager's conscience, so to speak, or his or her responsibility to keep track of them, but invariably the BitTorrent and software piracy channels were absolutely filled with Windows XP volume license keys and volume license versions. It was really difficult or impossible to audit the use of that software. In Windows 7, I shouldn't say all, but at least in the business world, activation is required. Now it says no for enterprise volume license, but if we look down into the very small print, it says volume license copies may require activation through key management servers. Bottom line is really, for all intents and purposes, product activation is required for all versions of Windows except for original equipment manufacturer or OEMs. This would be top PC makers like HP and Dell and IBM who are selling those computers or leasing those computers to their customers and have Windows 7 already installed. Of course, any activation requirements are removed there because the OEMs are deploying so many instances of that software. So we have OEM or original equipment manufacturer. You've got the Windows Anytime Upgrade program where you can pretty much just dynamically shift from one edition of Windows to another. We have the retail off-the-shelf upgrade version. We have the retail full packaged product, or FPP, most expensive pretty much. And then what we're concerned with primarily for our 685 exam, the enterprise licensing or volume licensing, where you know on the front end you're going to need so many activations for Windows 7. So specifically what we need to know is down here, and we need to know just a little bit about this on the 685 exam. Bottom line is, if you're a very small shop and you have fewer than 25 PCs, and you are a volume license customer of Microsoft, you'll want to do what's called multiple activation key, or MAK, product licensing. And this is where Microsoft gives you a single PID or product ID, and you can deploy it to that number of computers. Each of those computers does go out to Microsoft.com and activate over the internet. So Microsoft has removed, in this case, the IT manager's ability to audit and control their software licensing. Remember, with XP it was just crazy. You had a volume license key, you could install it 5 million times, theoretically. But here with Mac, Microsoft checks down the list. If you've purchased, say, 10 activations, Microsoft is keeping track of those, and when you go to install your 11th machine, that machine's not going to be able to activate, okay? Now, a requirement to use KMS or Key Management Services in Windows is you have to have at least 25 PCs. And all you need to know about KMS is that this is a free service that we can install in Windows Server 2008 that, in effect, you become your own local in-house activation server. So as you install your Windows 7 desktops, they still activate, but they activate to a local source. And the only machine that actually goes out to Microsoft is your KMS server. And another interesting point about this is that the client computers periodically refresh their activations. And then again, on the back end of things, the KMS server goes up to Microsoft. So Microsoft is still the big brother who's controlling the number of activations that you have. Makes it a lot harder to be dishonest, but really that's the best way to go. Wouldn't you agree, to be honest? In our second demo, we're going to look at the final two subjects of this nugget, device driver signing, and then I'm going to go out onto the web and I'll show you some appropriate and very useful licensing resources for Windows 7. Let's now complete this demo by taking a look at driver signing options and Windows licensing. This tip deals with user account control and actually serves as a nice segue into our consideration of driver signing. For an executable program file, we can right-click, come to Properties, and on the Compatibility tab, you'll notice it says Privilege Level, run this program as an administrator. So this is how, if you wanted to, you could force the instantiation of the administrator access token for an application and thereby prevent normal users or traditional users from running that application. I also wanted to show you this because for digitally signed software, on the property sheet you'll notice a Digital Signatures tab where you can see, for instance, the name of the signer, if there is a contact email address, timestamp, or then if you hit Details, you can view the specific digital signature details for that device. Now, as far as device driver signing options, what you might be used to, at least as far as the old Windows XP was concerned, is that we can right-click Computer, come to Properties, and then here in 7 we'll do Advanced System Settings to open the System Properties control panel. You'll remember under XP, on the Hardware tab, there used to be a driver signing option. Notice that that's not here because driver signing is much more robust than it was with XP. But we do have this option called Device Installation Settings, and what you can do here is just allow Windows to download driver software from Windows Update, or you can have some control here. Always install the best driver from Windows Update, never install driver software from Windows Update. Now if you're using your own WSUS server and you have a local Windows Update source, that may be fine. If not though, and you want to strictly control the device drivers that are being installed, be aware of this option because it can sneak up on you. Of course, we have our friend Device Manager, which we can open up several different ways. Perhaps the easiest is to simply type Device Manager into the search box. But if we expand a hardware item in Device Manager, give it a double click, this will tell you on the Driver tab if it's been signed and who signed it, Sun Microsystems in this case. And if we go to Driver Details, it's possible to view the digital certificate for that device. Another place we can check is Group Policy, local group policy on the machine or an Active Directory. We are under Computer Configuration, Administrative Templates, System, and there's a couple here. We've got Driver Installation with two policies. One, allow non-administrators to install drivers for these setup classes, which of course allows delegated administration. You could give non-administrators the ability to install certain device drivers. Turn off Windows Update Device Driver Search Prompt, which was what we saw in the GUI a little bit earlier. And then under System we have Device Installation with device installation restrictions. That deals more globally with how to limit users' ability to install hardware, but you get the idea. The final thing we'll do is launch the SIG Verif tool, the file signature verification tool, and it tells us here to help maintain the integrity of your system, critical files have been digitally signed so that any changes can be detected. And we can go ahead and check. If we click Advanced, this is simply dealing with logging, how verbose our logging is, and then we start the scan. What's neat about this is that it tells us how many files were found, how many were signed, and then of course what we're interested in are device drivers that have not been digitally signed. So it tells us the specific name of the device, where it is, its modification date, and its file type and version. Interesting to know. Those all happen to be non-Microsoft items, so I'm not perfectly surprised that that was the case. Of course, I was able to install those non-signed drivers for two reasons. One, I installed those drivers as an administrator, and number two, I'm running a 32-bit version of Windows 7. Remember that only the 64-bit version of 7 prevents unsigned driver installation. In terms of learning more about Microsoft licensing, Mac, KMS, full packaged product, volume license, all that kind of stuff, I have some good resources for you. This will take you well beyond what's covered on the 7685 exam, but in my opinion, it's crucial for you to understand this stuff to be a successful Microsoft support engineer. The first site is from zdnet.com, and this is an article by Ed Bott called What Microsoft Won't Tell You About Windows 7 Licensing. And this is where I pulled that image that I showed you in the earlier whiteboard. It's a great, great article, and there's at the end of it some additional links that you might want to take a look at. Another site you need to know is Microsoft.com/licensing. This will explain everything about licensing, how volume license works, briefs, all that kind of stuff. Finally, there's ladylicensing.spaces.live.com. This is a woman from the UK named Emma. In fact, her blog is called Emma Explains Microsoft Licensing in Depth, where Emma, who's a licensing escalation manager in Microsoft UK, has articles on just about every type of Microsoft license under the sun. I think among these three sites, you're very well covered as far as supplemental information is concerned. Handling new software installation issues review. We covered quite a bit in this nugget, but then again, we're going to cover a lot of information throughout this entire course, so get used to it, friends. First thing we did is we looked at user account control and managing installation permissions in Windows 7. I hope you see that user account control is much more elegantly instantiated in Windows 7 than it was, say, in Windows Vista. Second, we looked at App Locker and its down-level analog software restriction policies. I hope at this point you understand how to manage a mixed environment and how to deploy App Locker policies specifically. Third, we looked at device driver signing, reviewed what X.509C digital code signing certificates are and why they enhance security in an enterprise, and of course we looked at how to manage those options in Windows. We concluded this nugget with an overview of licensing options in Windows 7, paying particular attention to the volume licensing approach, which involved, remember, the Mac and KMS product activation strategies. I hope that this has been informative for you, and I'd like to thank you for viewing.